there's my matrix of error terms. This error term of 1.32, which observation is that for?
Times E.
Anything? 1.32. Which one is it in the error term?
So B times answer.
It is for the second one. It goes right here, 1.324. And then the next one would be 1.70, 0.234, and then 0.182. But then here, this one, does this have an error term? No, because we didn't include it in this regression. And so here, we would start the next one right here, 0.925. Just regular 1.032 and 2. Neato gang.
Yeah, but you still
So that's where those go. And I'm pointing that out because now we need to create the lagged values of this. So the lagged value of the error term, we're not going to have one here because there's no previous error term, but this one would be 1.324, right? This previous error term here is this one. Previous error term here is this one, so negative 1.740, 0.234. The previous error term here doesn't exist. So then we get negative 0.989, 0.032, and negative 1.032. Oh, this is 1. Does that make sense? Yeah.
Is there a reason, maybe I'm just thinking too much of it, but if you add 1.324 and negative 1.740, it'll give the same answer but just a negative of 0.234 and 0.182, and it's the same way for the other one.
What do you mean? Say it again.
So if you add 1.324 with negative 1.740, you get like negative 0.416.
Yeah.
And if you add 0.234 and 0.182, you get the same answer, but it's positive. And then if you do the same with the other ones, it's the same. So I was asking, is it that for a reason? Or?
Maybe. I don't know.
Okay.
Seems like quite a coincidence to just be a coincidence. We're using previous GED. I don't know. I mean, it's probably somewhat coincidental, but we could probably figure out like a mathematical reason. But it's not like, it doesn't help us in any way, I guess, for Durbin Watson.
I just thought it was for some reason.
It's pretty captivating. Alright, so now it's these 6 numbers or these 6 rows that we're going to use to calculate the numerator of the Durbin Watson. The denominator will use the whole 8 values that we have for this. That's what goes in the denominator. So now I will turn to the calculator, but I will point out that there is no shame, I don't know what that is, in just doing it by hand. Because now it's just telling us take the difference between them, square them, add them up, square the error term, add them up. You could do this by hand fairly easily. So if the whole calculator stuff is really confusing you, then just, you know, well, I'll get to the answer and you can figure out how to do it by hand and make sure you do it. But I'm going to do it with the calculator. Use calculator also. Alright, so I have my error term stored in matrix E. What I'm going to do this, to set up this matchup, is what I need to do, where I've got this column of the error term and then this lag value. I'm going to move this back into my lists. So I'm going to do that with second stat, going over to operations. At the bottom is matrix to list. I'm going to select that. I'm going to select my matrix E and then list 1. And then all I have to do is hit enter, and it has now moved that matrix into the list. So if I go to stat edit, we can see there's the error term right there. Sweet. Good? So now I need to take this list and put it in list 2, but shift it down 1 row. And so I'm just gonna put a 0 in right here. And we did this already before with one of these, I don't know, getting the GP all lined up by putting in the 0 or putting in the average, I think we did, or something like that. I don't remember. We did something. Autocorrelation, when we did autocorrelation. Here, just put a 0. For doing the Durbin-Watson, I'm just gonna put in a 0. And then I can go to second stat in operations. Number 9 is called augment. Augment will allow me to take list 2, which is just 0 in the first row, and augment it with list 1, or add list 1 to the end of it. And then I'm gonna store that in list 2, because it'll just create it, not store it, but I'll store it. So now when I go to list 2, I can see it has added list 1 to the end of that 0. Cool. Good? So now I'm gonna delete this last one, and also note that we have another space in there. We have another one that should be 0. That this first one, the 1.324, doesn't have a matchup next to it, but same for the negative 9.29, or 0.929. So I need to put a 0 here as well. And that's just gonna mark it. I'm gonna have to put zeros again in a minute. But does that make some sense so far? Okay, good, fantastic. So now I am ready to calculate the things I need for the numerator and denominator. The numerator is take list 1, the error term, subtract list 2, the lagged error term, and square it. So I will do that. I will do list 1 minus list 2 squared, and store that in list 3. And then it says take list 1, the error term, and square it. So I will do that, list 1 squared, and put that in list 4. So now I would go, look at these, and this first one here, list 3, I need to change to 0 where it was 0, and here I need to change it to 0 where it was 0. Because it's now we need to add these up, and I want to not count those. So putting in 0 will not increase my sum or decrease my sum at all. It will just keep it the same. So in list 3, I put it there. List 4, I leave the same. Cool? Okay. And then, what does it say to do? Yeah, well, take the sum and then divide one by the other, right? So I'm gonna do the sum of list 3 divided by the sum of list 4. And there it is. It could be what? So what does it mean? What if I said, I can change my red here. Look, it's all, I gotta, don't look at the answer yet. So if the lower bound was 2 and the upper bound was 5 for the Durbin-Watson, what would we conclude?
The lower and the
We got 2.8. I'm gonna point out that
Some of it.
these 3 are just really great cheat sheet material. Those 3 sentences, slap it down. So D is the Durbin-Watson statistic. We got 2.9. The upper bound is 2.5. So if I plug in if 2.9 is greater than 2.5, yes it is, then there's no autocorrelation problem. If it were less than the lower bound, so if 2.9 were less than 2, it's not, then there is an autocorrelation problem. If it's in between, so if 2 is less than 2.9, which is less than 2.5, which is not true, then it would be an ambiguous result. Does Does anybody, I asked last time, what's the logical symbol for otherwise? Anybody know?
I think this one. Little, this one.
Like a little L, like this?
Yeah, I think something like that.
Something like that, or it's like a half L, right? Like that?
Yeah,
I don't know.
I think.
Okay. And I'll look it up. Otherwise. There you go. So that is our conclusion. There is no autocorrelation problem, which means, no autocorrelation problem means that the error terms are not sequentially correlated. So one doesn't predict the next one, which doesn't predict the next one, which doesn't predict the next one. We don't have that problem. That's no surprise, because our regression included the previous year's GDP. So we included the lagged variable to correct for any autocorrelation problem. So we shouldn't have any. We indeed find out that we don't, so that's great. Feel good about that? Do it again. Question 6 now, the country. Okay, so I'm going to clear my lists. To do it again. So for that one, I had that stored in D, or C and D. So C is my matrix of Y, and then D is my matrix for X. Where here, I'm not including the lagged values of GDP, it's just a constant and an indicator variable for which country we're in. So are we gonna have an autocorrelation problem? Probably, right? That we can look at the data and see that it seems to be serially correlated, that this year's GDP does look, and we found last time, is predictive of next year. And so not including that, there's probably gonna be a problem. So we kind of know what to expect from Durbin-Watson. Let's see if we get that thing. So I need my betas. This is in 4 this time. And y is in 3. So that'll give us the betas. How did we interpret these ones? Can't see. Last time I can see. Maybe it just needs a little cleaning.
Didn't help.
Much better.
A little bit. What is this blotch?
Ooh.
Well. Okay, so now you can see. You have no excuse. Let's think differently. Beta 0, 65.6. Our only variable in there was an indicator variable for which country it is. So if you are in the country of GBR, what value do you get for your predicted GDP?
57.
Yeah, 57.6, because we get 65.6 plus 1 times -8, or -8, gives us 57.6. And if we're in AAR, it's 65.6 plus 0 times -8, so you just get 65.6. What are those? 2 values, 65.6 and 57.6.
Those are your things.
Yeah, the average. I gave up. The average of each of those groups. Because that's all we told it is the groups. And so regression is just telling us, oh, the average for that group is this. That's all regression is ever doing, is giving you the average for the groups that you specify. So if you have multiple variables, then your group is people with a 1 for x1, and a 3 for x2, and a this, and a that. That group has an average of this number. That's what the predicted value is. Does it make sense? Illuminating, very illuminating, extremely illuminating. So those are my betas, but I'm after the Durbin-Watson statistics, so I need to get the error term. So I will get that by taking y minus x beta. I'm going to put that into matrix F, just like that.
Is he doing another problem or just same problem? Just
So it's Durbin-Watson again, but with question 6.
那我们明天吃好了睡觉。
Cool. So now what do I do?
明天
I need to put that into my
1
list.
点钟开始。
Exactly right. So I'm gonna go to operations, matrix to list. Well, still.
What do you think Shu's gonna get?
Matrix to list. My matrix is F. My list will be 1.
主要我在准备一下，
There it is.
我也在想。
And then what am I guess I need to go into list 2. Put a 0.
Put 0.
And then I need to add list 1 to the end of list 2. By doing what?
我也觉得
Augment?
Augment. So list 2, comma list 1 gives that, and I need to put it in list 2.
我也在想这个问题啊。
So now I have that. Now, which ones need to be 0? No, I'm not going to do it. So, the first term doesn't have a lagged error term. But here again, we're breaking it apart by country. This, so we go 1, 2, 3, 4, 5. This one right here is the first error term for AAR. It also doesn't have a lagged value. So we put in a 0 there, and then this last one we can delete. So we have these 4 numbers for each
我
country,
线没带，没带我这个，
and zeros out.
这个线应该是可以重叠。
So now what?
L1 minus L2 squared?
Yep. Nailed it.
Stored it in list 3.
I'll put it in 3. And then
L1 squared?
L1 squared, put in 4. And then I need to go back in, and I need to adjust these to 0. You can see they're very bizarre numbers compared to the others. Adjust those back to 0. And then do,
真的很有可能就是重叠一下。
that's right, sum, list 3, divided by
Let's see. Okay.
sum of list 4. So I got 0.44. If my lower bound were 2, my upper bound were 2.5, what would I conclude? Which one?
The second one is auto correlation.
Yeah, because 0.44 is less than 2. That's true. There is an autocorrelation problem. The error terms are serially correlated. One predicts the next one. And that violates our assumption of independence. They're not independently random values. And so it is violating our core assumption, the most important one.
Where did you get the lower bound and upper bound?
Table. I actually just made them up because I didn't want to look up the table. I will give them to you on the test. I will say the lower bound is this, the upper bound is this. What do we conclude?
Wait, this last one though.
Oh, yeah, yeah.
Are those slides on posted?
I don't know, are they?
No.
They're not.
Yeah,
Time
just-
series
just
isn't.
asked you to see it.
Oh. Can you wait? Yep, email me. I don't appear to have an email. How about that? Email and remind me and I can do it once this class is over and I go like this. Good call. Those would be needed. Alright, so that's our Durbin-Watson for that one. Now we can do Durbin-Watson for number 5, where we just did the lag values of GDP, which I need to go back in and edit my matrix B here. This is the one I created to do question 7. I'm gonna get rid of this last one, so now it's question 5. Because it's just the lag values of GDP, not country as well. And then I do extra. Get betas. Constant. Coefficient for last year's GDP means we're carrying over last year's GDP and growing. We're growing the last year's GDP by this and then adding this on to whatever we had as well. So that's exciting, a lot of growth. high growth countries.
上次我转多少
GDR.
？23。
So now what?
上次我也想说，
You get that error too.
你 need to get that error.
这叫 also。
So I take this, y minus x beta. I'm gonna store that
有个傻逼说要
in
做
G,
30，也不知道
yeah,
真的
G.
假的。一个傻逼
and。then
Store it in this.
put it into a list.
是不是跟我说？是不是
In the list
那
one.
个傻逼说他一个同学做30。
And then in list
这个傻
2,
逼的话，我
I
是不会
need
记
to
得。是哪个傻逼啊？
get rid of
上
these,
节
but
不是
keep
说那
that
个
0 at
地
the
方上
top.
节牌，不能闹牌。
And then I can
你应该
augment
不认识我。
list 2 with list 1. Store it in list 2. So now I have that. I need to put in a 0. Where does the 0 go? Hints. That one. And then delete the last one. Good. And then list 1 minus list 2 goes into list 3. And then list 1 squared goes into list 4. I hope that worked. We should look. Oh, it did.
我
Good.
们样子也不是很好看。
So then list 1 oh, I did it wrong though.
这个时候
You
这个
just square
会
list 1
死吗？
minus list 2.
Yeah, don't forget to do that.
这个好规矩。
Otherwise you'll be completely wrong and you'll fail. At this
日
test
本
every
经常
time.
吗？你觉得值不值？
Now what?
Add zeros into list 3.
14可以的。
Oh yeah, did I do that?
No.
14可以进一笔啊。
Good call. I'm failing my own exam.
真的假的？
Adding zeros into list 3. And then, I think I forgot to do that in the last.
这整个都进来，这个
Yeah,
日
we're
本
gonna fail. List 3, sum of list 3 divided by this one. Sum of list 4.
Oh.
2.9. We got like 3.6 left. That's 2 point, that's the answer.
It's just a survey. Yeah.
So we don't need to mess with list 4 at all. Like we adjust list 2 and 3. We don't mess
Yeah,
with 1
right.
and 4.
List 4, you let them It's 2.9, what do we conclude?
Conclude that it's no actual correlation problem.
Greater than the upper bound, no autocorrelation problem. No surprise there, because we included the lag variable, so there shouldn't be a problem. Questions about calculating the Durbin-Watson statistic? Okay. Calculate the R squared for 5, 6, and 7. What? How do we do that?
Make a difference.
It's standing right behind me, isn't it? Oh, that's awkward. This is how, yeah, okay, good. R squared, 1 minus SSE over SST. This is like exam 1 stuff. So if you were wondering if it's cumulative. It's cumulative. SST, if you remember, you do the variance of y times n minus 1. So, we need to get those numbers. How do we get those numbers? What do I do? How do I do it?
I know. So variance y, you could, that should be matrix A, right?
Yeah.
So you could take matrix A, start at a list 1, and then
Yeah.
calculate the variance.
I could absolutely do that. I want to do SSE first though.
Oh, SSE.
I mean, you can do it that way.
We should
No,
start with
you
SSE.
can't. But I'm gonna start with SSE. How do I get SSE?
It's not like y hat.
What?
Sum of squares error.
There's one question that's like really hard.
ET minus
The rest of them are easy.
minus 1
So this is minus y minus y
我
hat.
明天在电脑上干嘛
Yeah.
呀？把视频拷
And
给
then
我。
add it up.
视频没什么
y
用，
minus y hat.
这个才
Have we done y minus y hat? what is y minus y hat? That is equal to the,
It's like the value
哦，
minus.
不是这个，这是另外一节课。
no, that would be y bar. Y hat is x beta,
我怎么找不到
x
啊？
sum beta, but y minus x beta is the error term. We already have those.
这才
And of course, we completely remember, so if
这
we
个是水
do,
笔，这是水笔，
which one do you want to do first? We can do this one first. Number 5,
这才是。
that error term was stored in G.
这只
And
是
if I
辅
do
助，
G
这只是辅
transpose
助，
G, or E transpose E is what that is,
可以的。
or error transpose error, is the
明天吧，不然呢？要不直接生
yeah,
产
sounds
就
better.
上网就会了。会呀，但是我那个电脑生成。
Okay, so what I'm gonna do, a little fun fact, because we got all those decimal places,
您看
I
也
can
是这
do
样。
answer,
是的。
parentheses 1 comma 1 in parentheses,
是的。
store, and I'm gonna do alpha E for error.
硬盘要考半个小时才能考走。
Now, giving it that 1 comma 1 will grab the value and then store that value in the variable E, and we can summon that later at will, which is very exciting.
进这
So
这
that's
哪
gonna
里套
be
流？
this number. Now I need SST, which we already determined. We can take our matrix A and put it into a list. So I'm gonna do matrix to list.
还有一个写
Matrix
下来。
A is going in to list 1.
因为这个
Now I
写
have it
下
in
来
list 1, and I can just do the variance of list 1 times n minus 1 is gonna be what? For that.
7
Yeah, 7. Because we had 8 observations, so we have n of 8. 7 is n minus 1. So I get this number, 276. And so I can just do 1 minus e divided by that number
看出来取消了。
gives us the r
我就会
squared.
上一个爱心了。打着打着，很生气吧？
So that's for number 5. Like, that's the r squared for the regression in number 5. How about number 6?
哎，不正好。你这会咋
The
办？
same procedure. We take our error term, which we put in F, transpose F, gives us this. And I'm gonna store it in E. And then I can do matrix to list. And this is my Y, is in C. I'm gonna put in list 2. Maintain some list integrity. And then variance of list 2, I really just done it. What's n minus 1 for this one?
9 9
9. Because we had 10 observations for this regression. 10 minus 1 is, yeah, 9. Let's subtract 1 from 10. So I get that. So then 1 minus e, divided by the answer. So r squared, or the regression in question 6. Fantastic. Okay? 7 is great. So we take the error term for that one, which we put into E, and then do E transpose E. We get that. We do answer 1 comma 1 into E, the letter E. You notice it's a similar number. And then variance of list 1 is the same, right? We don't need to transfer A again into list 1. It had the same dependent variable. So we just do the variance of this times 7, because we had 8 observations at minus 1. Gives us that, and then 1 minus E divided by answer r squared. That's the whole thing. 2 versions of the final exam. One of them I'm not gonna give you, any of the classes. But just to show you, study guide. Yeah. Study guide. Exam. I rearranged the letters, put them in order. D-O-G instead of G-O. So funny. The questions are almost identical. Question 1 is worded slightly differently. These ones are worded the same, different numbers, for number 3. These ones proceed the same. Number 9 and number 8 are switched. So that number 8 is calculate Durbin-Watson, number 9 is interpret. 10 is R squared. I don't make you do all 3, I tell you which one to do. And then there's an extra credit question about Star Wars. Oh good, I did have that. Oh, that's funny.
What do you say after 9 and 10 were switched?
The extra credit, I can ask, I'm
Oh,
just
after
an extra credit question.
10 is R squared.
Extra credit question last semester. In Star Wars Episode 4 New Hope, what are Obi-Wan Kenobi's last words spoken to Luke Skywalker just after the explosion of the Death Star? And then I like that in my equation sheet, Jedi Master Obi-Wan Kenobi, played by the legendary Alex.
Can you tell us like what movie we have to watch?
Yeah, Return of the Jedi. Yeah, it's also a last words.
Wow.
Yeah. It's great. It's one of my favorite lines actually, in movies I quote it all the time. Last words, Obi-Wan Kenobi to Luke Skywalker in A New Hope. They aren't the last line in the film, but they're the last, like, I think, scripted line in the film. So that's an example. They blow up the Death Star, and then he arrives back, and they're celebrating, and they're like, well, I think they do say, like, they pull R2 out, and C-3PO's like, we will return, won't we? So I guess that's a script. Obi-Wan's last line. Nobody. Bonus
Yeah.
points if you could tell me his
Isn't it-
last line while alive.
Doesn't he say like, if you strike me down, I'll return stronger than ever?
He
That's
does
his
say
last
that.
line. That's not his last line though.
I don't know if that's, actually, now I don't know. Now
Yeah,
you got me
see?
all wondering. I think his last living line is only a master of evil. Right? Because Vader's like, when last we met, I was but learner. Now I am the master. Only a master of evil. He might then say, if you strike me down, it becomes more powerful than you possibly imagine.
Yeah.
That might be his last living words. But his last words after the explosion of the Death Star are just great advice for life. Nobody, 0 people know this? Y'all, the worst. It's, remember, the force will be with you.
Hold on, you have to
That was on the start, the first study.
Oh.